It's time to play What Went Wrong? Yes, ladies and gentlemen, that is an incorrect answer. I did it wrong. Can you find my mistake? It is right here. That positive 2x in the parentheses right there. I made a mistake when I did distributive property. So let's do it correctly. When you do this, you're going to take the negative 2 times the 3, which worked out fine for the first one. But then you take the negative 2 times the negative 2x. Keep the sign with the term. So it ends up becoming a negative 2x on the inside. Negative times a negative is a positive 4x. So instead of getting 3x in the final answer, we should have gotten 11x. I bet you found that, didn't you? I know, but it's pretty, isn't it? I mean, this is how you want to add fractions, because if you're multiplying fractions, you multiply the numerators and you multiply the denominators, and that just makes so much sense. And then we teach you how to add fractions, and you're like, why can't it be like that? Because it's not. It doesn't work. You have to do it differently. So the problem is you got to come up with a common denominator. So the problem here was that 3 plus 5 down there. You can't have it like that. You still add the numerators, but they're not even going to be these numbers. They're going to be different numbers. So here comes the correction. All right, we got to come up with common denominators. This is the one that has a lot of work, is adding fractions. Subtracting is the same. So what I'm going to do is take this 2x over 3, and I take the top and the bottom times the other guy's denominator. 5 on the top, 5 on the bottom. And we're going to do the same move for the 3x over 5. We take it times the other guy's denominator, which is 3. Now we have common denominator of 15. We're going to add them together, but the numerators are not going to be 2x and 3x. It's going to be 10x and 9x, because you multiply the 5 times the 2x and the 3 times the 3x. Now, add the numerator with that common denominator, and there we go. Now, if this wasn't in lowest terms, you would have to put this in lowest terms, but that is such a minor mistake once you get to the end. Not even knowing you need common denominators. That's a big mistake I made there, but that's a common mistake. I see it in real life all the time. I'm going to do another problem wrong. Are you ready? Again, why not? Why can't that be right? Because it's not. Mathematically, it's not right. This is the problem right here. Again, multiplying radicals is nice because you multiply the numbers on the inside and put them both underneath the square root sign. Multiplication is like the nicest operation. It's like the sweetest person you've ever met. Addition is not so much. So here's how we have to do it for real. That square root of 12 is the problem right now. Square root of 3 is about as simple as it can get, so all I'm going to end up doing is copying it down. But that square root of 12, you got to break that up. You have to simplify square roots. So we're going to multiply 4 times 3 here. I mean, you could have done 2 times 6, but 2 and 6 aren't perfect squares, and they're not going to help you. So we want 4 times 3. And the square root of 4 is 2. I'm going kind of fast here with this, assuming you've seen this before and just forgot. And then we have 2 root 3 plus another root 3. That's like 2 cookies plus another cookie. You have 3 of those cookies. Hey, this was fun. I think I want to do this again. What are your favorite math mistakes? You know, the ones that you make all the time, even though you know better. Tell me, and I'll go find problems so I can do those for you, and you can correct me again. Thanks for watching. I'll see you guys next time. Bye.